right, so let's take a look at our day 3 notes. What we are working on today is we are working on multiplication. So last class you had your whole little classifying thing, your cubic, linear, quartic, your quadratics, going by the number of terms also. So now we're going to go a step ahead and we're going to get into multiplying. Now one thing we have to keep in mind is if we have anything raised to the 0 power, a lot of people are going to stand here and tell me that it equals what? 0. It does not though. Anything to the 0 power equals a 1. You can even take a second and try it in the calculator. Put any number in the calculator, raise it to the 0 power, you're going to get a 1 every single time. Go ahead and do that. So that's just a little rule that we have to memorize and know. So when we are multiplying, what we need to do is any coefficients, you are going to multiply those first. Keeping in mind coefficients are your what? Coefficients are your numbers out in front. So you multiply those numbers first. You're then going to keep your like base, and we add the exponents. So for example, if I have x to the a times x to the b, this would become x to the a plus b. You would add your two exponents together. For my other example over here, I have 2 to the third times 2 to the second, so I keep my base of 2, add my exponents, 3 plus 2, gives me a 5. But since that's actually a number, what is 2 to the 5th power? You can use your calculator. So whenever it's a number to an exponent, you always have to figure out what that is. So multiplying, we add those exponents together. So like for our first example, I have c to the second times c to the fourth. So I'm going to keep my c, add my exponents, so I get c to the sixth. Why is this confusing? So this next one, I'm going to multiply my coefficients. Negative 2 times 5 gives me a negative 10. I then have a base of x, so I'm going to keep my base, add my exponents, 2 plus 4, gives me a 6. So I have negative 10x to the 6th. So example 3, we have a couple letters here, but you just do each letter on its own. So first you multiply your coefficients, negative 3 times negative 4 gives us a 12th. Now we're going to deal with the a's. So a squared times a to the 4th, add those exponents, we get a to the 6th. Now we'll deal with the b's. I have b to the 3rd times b to the 1st. So 3 plus 1 gives us b to the 4th. So our final answer is 12, a to the 6th, b to the 4th. Maybe. All right, number 4. What's my coefficient here in front of my xy to the 3rd? A 1. So I got to do my 1 times my negative 3. What do we get? Negative 3. So for our x's, I have a 1 plus a negative 3. Negative 2. For our y's, we have a 3 plus a negative 2, which would give us y to the 1st. Would I have to write that 1 though? No. But you can leave that there. Now 5, this is the one where you guys still make some mistakes on this one. Our base is a 3 because that's what has the exponents attached to it. So I just keep the 3 and we just add our exponents. So negative 5 plus 2 plus 7. 4. And again, since this is a number just to the 4th power, what is 3 to the 4th equal to? 81. So 81 would be our final answer. So next one, again, same thing, just another way of writing it. Multiply your coefficients. Negative 4 times 5 gives us negative 20. What happens to our a's this time, though? Yeah, because 2 plus negative 2 would be what? 0. So if I get an exponent of 0, I don't even have to write that letter anymore. So our a's canceled each other out. We get b to the, no, fifth. This is a 1 here. 1 plus 4 gives us a 5. So negative 20, b to the fifth. So now we're going to change it up just a little bit. If you have a power to a power, so what that means is I have x, let's say, to the second, and then it's also to the third. That's what we call power to a power. So you have 2 exponents. We didn't have that on the other ones. I was just multiplying 2 separate x's. Here I only have 1 x, and there's 2 exponents on it. So you're going to keep the base, and we multiply the exponents this time. So if I have x to the a to the b, I multiply those and I get x to the ab. Now if you have a couple of different things in the parentheses like this and you have an exponent on the outside, you still have to give the exponent to both of them. So this is 2a to the c, so this becomes 2ac. And then x to the bc, because you multiply your b and your c. So power to a power, you've got to multiply your exponents. So our first example, I have 2 exponents, so power to a power, so that tells us we need to multiply. So that one turns into x to the 8th. For our second example, what are the exponents on the 2, the a, and the b? Those are all 1s. So I have to do the 4 times those 3 1s there. So this becomes 2 to the 4th, a to the 4th, b to the 4th. You're multiplying all those exponents. So the last thing we have to do for that one is we just have to clean it up, because I can't leave it as 2 to the 4th. You can never leave a number to an exponent. You actually have to figure out what that number is. Nope, 16. So 16, a to the 4th, b to the 4th is our final answer. So again, in example 3, what's our exponent on the negative 3? And the exponent on our y? 3. So now we can multiply all those times a 3. So negative 3 to the 3rd, and you always want to keep your negatives in parentheses like that. 2 times 3 gives us x to the 6th. 1 times 3 gives us y to the 3rd. Yep, so negative 3 to the 3rd gives us negative 27. X to the 6th, y to the 3rd. Okay. So number 4, if we take a look at it, we have all this to an exponent times all that to an exponent. So our order of operations always tell us to do what? Multiplication or exponents first? Exponents first. So I need to multiply here, so I get x to the 12th, y to the 8th for my first term, times, let's multiply out the second one. So I'm doing them times negative 3, so I get x to the negative 6, y to the what? No, negative 3 times negative 3 gives us positive 9, so we get y to the 9th. Now we have to go back to those multiplication rules we were doing up on the top now. Now we add our exponents, because I have 2 x's I'm multiplying together, so I add those exponents. So 12 plus negative 6. 6, so I get x to the 6th. 8 plus 9 gives us y to the 17th. So it does get tricky when you have to put those 2 rules together, but as long as you keep practicing them, you'll be fine with it. So for 5, we're trying to add. So thinking back to your notes that you had to have done for today, adding means you have to have what be the same? The bases have to be the same and the what's have to be the same. Exponents. So everything has to be the same. First thing we have to do is take care of this exponent over here. So this becomes x to the 6th, y to the 4th when I take care of my power to a power. So now do I have like terms? Yeah, I got x to the 6th in both of them, and I got y to the 4th in both of them. So we can actually add these together. So we did have to do 7 plus 1 gives us what? So 8x to the 6th, y to the 4th. You do not add your exponents when you're adding like terms. Yes, distributive property. Remember, that means we multiply through the parentheses. So I did a times b, and then I did a times c. And you add the two of those things together. Bless you. Bless you. So looking at our first example here, I have 2x that I need to distribute through. So I'm going to do 2x times my x squared first. So keeping in mind, you have to multiply your coefficients. 2 times 1 gives me a 2. We're multiplying, so I need to add my exponents. So that gives me a 2x to the 3rd. So now 2x times 3x. So 2 times 3. And then x times x, we add our exponents. We get an x squared. And then times the last one, 2x times 4. 2 times 4 gives us 8. And then the x was with the 2, so it still has to be there. So 2x cubed plus 6x squared plus 8x is our final answer for that one. None of those are like terms, so there's nothing we can add together. Well, some people write big, so I give them space to write big. All right. So number 2, we're multiplying first times the z to the 3rd. So again, my coefficient here is a 1, so 3 times 1 gives me a 3. Add our exponents on our z's, we get z to the 7th. And then we had a y with this term on the outside of the parentheses, so we have to still have a y even though there's nothing to multiply at times. Nope, it'd be y to the 1st. So now we need to multiply times the second term in there. So 3 times our -2, -6. Again, there's no z here, so I'm going to keep it as z to the 4th. But then y times y gives us y squared. So there's our final answer for that one. So number 3, what do you think we do first? Yep, we have to distribute our 4. So 4 times 2x squared, 8x squared. And then 4 times -3 would give us a -12. And now we have to distribute your -3. So -3 times -2x squared would become a positive 6x squared. And then -3 times -5 gives us a 15. Do we have any like terms to combine there? Yes. 8x squared plus 6x squared gives us a 14x squared. And then -12 plus 15 gives us a 3. So that's our final answer, 14x squared plus 3. Now, number 4, a very commonly made mistake is people try to subtract your 8y and your 2y first, but you can't do that. You have to distribute your 2y first and then combine your like terms. So this 8y is going to stay as 8y for now. So now we have to do negative 2y times 7. So that gives us a negative 14y, because negative 2 times 7 is negative 14. The y has to be there still. And then negative 2y times negative 3y become positive 6y squared. You add your exponents. 1 plus 1 makes that y to the second. And then we have our plus 5. So now when we write this, all these other ones were already in standard form when we wrote our answers. This one we have to make sure we put it in standard form. So which term should come first? The y squared. Largest exponent always goes first. So now, 8y minus 14y, what does that give us? Negative 6y, and then our plus 5. All right, then our last example, you can always have your calculator help you when you multiply with your fractions. 1/3 x times 3x squared. So our 1/3 times our 3, what do we get? 1. X times x squared would be x to the third. I add my exponents. So now 1/3 x times 15x. Negative 5 x squared. And then our negative 1/3, or sorry, our 1/3 x times 27. 9 what though? 9x. Since that x is with the 1/3, it would also be with the 9. And then there's our final answer. So yeah, it can get kind of confusing. You just got to take your time and go nice and slow.